the question is, what is the syllabus for the midterm? And the syllabus is all material we've covered up through today. Which reminds me, let me just, okay. So if you go to the course website, there's now a section that contains a list of previous exams. That should be enough examples, right? And there's a gap because there was a gap in when I didn't teach a course for several years. And let's see, the other thing is there's always all these unforeseen effects of your actions. So you say, oh, the exam's going to cover all the material up through today. Then it's like, oh, what should I cover today? I wanted to cover cohesion before the exam. It's like, oh, we're not done with the coupling yet. And if I talk really, really fast, maybe I can go through a cohesion. It's like, and usually it's like a bad idea to like rush through things so I can put on exam. So to make sure I didn't do that, I didn't post notes on cohesion. So we may end early today. And the reason is I didn't want to be tempted to talk about cohesion until after exam because we wouldn't be able to cover the entire.
Are we responsible to read those essays?
What?
I'm waiting on my book. I ordered a book. It hasn't.
Yeah, the book is really cheap now. It's like $5. And I bought the original copy for like $40, and that was, these days that's not much for a book, but this was like 15, 20 years ago. I mean, it was expensive back then particularly since I had read most of it online. Any other questions? No. There might be some questions next week, right? Right. So we're talking about types of coupling, right? We talked about data coupling, which in this context was, basically you pass in data to a method return it. Control coupling, where you're passing in sort of flag, which we use internally to determine what we do, or we pass back some sort of flag, which then determines what the caller does after we're done, right? And then there's global data coupling, which is what it sounds like, right? You've got a piece of global data that you then access. Um, um, but then right? These are global, right? And so he then tries to figure out, how to rank them. And well, you make a reference to an external object, right? There's some global object system.out, right? It is an object, right? Because it's some sort of stream and you write to it. And then, okay, but the first one is like we might use that for in Java to be a lock, right? And so we want one object to actually lock because we may want to have a lock uniform on across the system as opposed to separate locks, right? And then this is more like system.out, right? We're calling a method on some external object. And so, yeah, there's some component, and this doesn't change state, so we can call methods on it. Now, we remain constant, but we're exposing the structure, which, okay, so this structure that makes it more coupled, because if we ever change that structure, then we have to go find all the places that use it. With modern IDEs, it can be too hard to find all those places, except, of course, if you've got thousands of files, you have to make sure all the files are loaded, right, in your IDE, otherwise you won't find them. And then now the data does change and we can access the structure. Right, so we're basically trying to figure out, we have an object, we use it, but we don't call it method on it, we just use it for some sort of, or we just call methods on it and it doesn't change its state, then it changes state, right, it's remains constant, but we can access the structure. We can't access structure, but it changes state. Right, and so that's the singleton, right? The singleton may contain state and may change state, but it's hidden from us. And then finally, right, it doesn't remain constant, and we can access. So it's just trying to measure, degrees of globalness and how coupling gets worse and worse, right? Internal data coupling. Originally it was just people like to dump on C++, and they say, oh, friends. In C++, you get what's called friends. And what do friends do? So if class A is a friend of class B, that meant that class A could interact with the hidden parts of class B. And people complain about it, but I think the complaints were slightly overblown because class B had to declare class A to be a friend, right? So it was class B saying that class can do this, right? So it's not like class A could say, okay, I want to get inside class B, and it could decide on itself. No, the designer of class B had to say, I need that class to be able to do this in this class. So that's what it's talking about here. But now when we get reflection, right, it's now possible in Java to use reflection to interact with the internal workings of another class. And actually, Have you ever used a debugger in Java? And the debugger can show you the values of the fields in an object that are declared private. How do you do that? How is a debugger be able to look at the private fields of your object and tell you what the values are? I mean, the debugger is written in Java, right? That's one way.
That's what I was saying. For all of it.
The only other way is if there's some special hooks in the VM that gives you access, right, that only they know about. But why build in special hooks when you have a general mechanism to do it? And if I can access them to see the values, why can't I change them? But it does show you, right? If you want a debugger, we need to be able to do that, right? And no one's going to say debuggers are bad, right? They're useful things. So even though he says this is the least desirable type of coupling, there are still common examples where we need it. And so for me, when you start saying this is evil, that's counterproductive. Is what we need to understand the trade-offs are, right? Having global data allows things to be coupled together in ways which become hard to find out, right? And then there's Python, right? Um, Python does have a way of making their properties private, right? But this is just a convention, right? The convention is you do underscore underscore name of the you name the property, it's underscore this, right? Underscore that. That's just a convention. You can still access it from outside by just giving the name object dot underscore this or that, right? And so, right? I mean, in Java, we go this whole thing about, oh, you've got public and private and protected and all these packages and all these levels that make sure we get the right combination. And the Python people say, just forget all that. Just trust your programmers, right, to do the right thing. So it's clearly a different philosophy. Um, right? I mean, we need a debugger, right? So we need that. And then there's content coupling. Um, you know, in C++, you have those header files, you incorporate them, and how many people here have done significant work in either C or C++? Just a few people, right? like ancient history, right? Right. So that was his take on coupling. But we also have design patterns which are designed to reduce coupling, right? Um, so one is abstract factory. How does that reduce coupling?
You never actually create it. So it's giving you an abstract.
No, you get a concrete object.
You don't know what it's interfacing. It'll always give you the abstract object.
Yeah, it doesn't know the concrete type, so it's almost the same thing, right? But it also reduces coupling to we can change the whole family, right? So our client code becomes decoupled not only from individual instances, concrete instances, but we can change that whole. We step back and say, look, our client now is decoupled from what family we want to create. The bridge. How does that reduce coupling? Yeah, we can vary the implementation without anyone knowing, right? So our client code is decoupled from the actual implementation. How does the chain of responsibility reduce coupling? And so how does that reduce coupling? So at runtime, we create the chain, right? So we are not coupled to a particular object, we're coupled to that interface, and we can build that chain differently each time, right? The command.
Command, you can change the works. The pattern. The point is, you just deal with the command.
Yeah, I mean, you said you have no, I mean, you're not coupled to what's going on at all, right? Just the command can do anything. The observer. Yeah, so the subject doesn't know about observers, right? It just knows it has a bunch of observers, and when I've changed, I just tell them all I've changed, right? We haven't talked about the facade, so we need to worry about that. We haven't talked about the mediator, so we don't have to worry about that. Um,
On observer though, there is kind of a strong coupling. With this, to know what changed, you have to go back and get this new state. You have to have a reference to the concrete
right,
subject.
right, exactly. Because there, so we have to be careful, right? Because what we're in the observer pattern, the subject is decoupled from the observer, but the observer is not decoupled from the subject, right? The observer has to know about the subject. He has to know what value it wants to know about, right? And how to get it. So yeah, the observers are coupled to the subject. The subjects are the ones that are decoupled. That's an important, yeah, distinction. Now there's a bunch of, you know, time marches on, right? And so there are a couple popular things which are happening now, which are interesting to look at in terms of coupling, right? So reactive programming is becoming popular, um, right? So Android a couple of years ago introduced reactive programming to the Android environment. We had this past summer, Apple introduced reactive programming to the iOS environment. Um, number of years ago, I forget how many years ago, um, Facebook introduced React to introduce reactive programming to the web world. And since that point, you know, a number of other big or common web frameworks have done the same. Um, and so, in part, they use the observer pattern. So you have a piece of data, and that becomes your subject. And then when the subject changes, the broadcast is changed to the components of the web page or the components of the application that need to know about it, right? So they can update themselves. Um, and they go a little further then, because then what happens is your architecture becomes, well, what you do is they talk about this single source of truth. And I understand that we have to talk about saving an application, right? So you got an application and you go to the first page and, oh, the problem is I'm going to display data, say student, your name and ID, and the courses you're listed in. Well, but when you do that, you've got your model, which contains that information, right? But then when you display it, your widgets that are displaying it also have that information. So basically, there's two pieces of it, right? And then you might have a text field where you can type in things, which can change the state, change that data in the widget, but not necessarily change it in the model. So now we've got two copies of it, right? And then we have to work to keep those two things consistent. Um, and then maybe you then have some sort of button you press and then you go to another page or part of the application, which has part of that data. And now again, you've got the model part and you've got the widget part, right? And so then, at least in the Android or iOS version, you'd have four copies of data, right? You got the model for the first page or scene or whatever you call it, and the widget, and then you got the second page, this model, and this, and then you go, well, you know, maybe want to store some of this in a database. So all of a sudden it's like, oh, now we've got 5 copies, right? And then of course, since we're in a network world, we may then, connect to some server to get some of the data. And so there's like, lots of copies, right? Um, and the reason Facebook created React was that the problem they faced is you had all these data sources, right? I mean, you got your friends and all their streams, right? And as one friend adds to their stream, adds to their status, it updates all their friends, right? Timelines. And then of course you got the ad stream, right? They continue updating that, and then now I got the news stream, right? And so you got your friend stream, the news stream, and the ad stream, and each one of those has multiple inputs. And what they found is that it got so confusing, and there were times when one of those things update, and then there's a little widget here supposed to had to get bigger because there's more information, and it tried to expand and it would expand, but the whole thing forgot about, they didn't know it, and then it was like, oh, it got bigger, and then else got moved out of the way, and the engineers were like, why'd that happen? I mean, I couldn't figure out why it happened because there's data was bouncing around all over the place, and there were too many copies, and it was like, no, we want the data in one place, and then what you do is when you want to change things, you just change the data. And since it's now the observer, right, it will then broadcast the change to everyone who registered to be interested in that piece of data, right? And so in React, what happens is every time the data changes, right, in theory, what happens is all the widgets get redrawn. Well, but in the background, they cheat. They look and see which ones depend on which data and which ones change, and they keep the ones that didn't change and redraw the new ones. And so the structure becomes, you basically create like a database in your program. Here's all the data we were interested in, and then everyone else registers. Like I want to display the student courses, right? So register on that piece of the data, and so when it changes, that part of the display will be updated. Right? Has anyone used React? No. Anyone heard of React? Good. Right. And unfortunately, there's a local company that had experience doing this, and there's a student in the class that worked for that company, and they had some problems, but the student isn't here today, so we can't ask him to comment on. All I know is that Chief Technical Officer says, yeah, we had some problems, had to roll it back. Like, he didn't have time to elaborate, so I don't know what the issues were. I've used it in small cases and it works nice, but lots of things will work fine in a small scale. So we can think of this several ways. We can think of it as, oh, we're just scaling up the observer pattern. We can also think of it as, oh, we just created a huge glob of global data, right? And now our entire program depends upon that huge glob of global data. And what happens when small scale is not too bad, right? It's like a little database internally. But what happens when the scale gets very big? I don't know. Facebook, their web pages are pretty complicated when
database, and then if you have multiple servers synced to that database,
Base.
then you can't always go back to the ground source of truth before you update UI element.
Yeah, so the single source of truth really is just for the application running right now.
So it is.
Yeah, it's a global memory situation, yeah. Now, in Android, what they do is you can have Android comes with a built-in SQL database. And so you can use that as your single source of truth, right? So your widgets can depend upon queries to the database. And so when the database changes, it will change that query, then your widgets are notified and they get updated. No, the database is locally on the device.
Okay.
Yeah. But now what you can do is you can pull, right, the central database, and what changes you can update your source of truth. So it's not clear to me how well this scales, but like I said, one of the things about being a computer science instructor is that you don't have time to work on big projects, right? If I was working on big projects, I wouldn't be here. I'd be having to work with deadlines, right? And right. So basically, yeah, you update the data, and then all subscribers of data get updated.
This isn't really.
No.
I mean, at least to some extent. I mean, I've never really used them. But Microsoft has always had. I don't even know if it's, I remember something like REX. I don't know if it was Reactive. But I mean,
Oh yeah.
it's a long time where you try to register your components
Yep.
with
Yep.
the database.
Yeah. So if you look at the history, 1999, some people wrote a paper about the system that was functional reactive stuff. And shortly afterwards, Microsoft started the RX stuff, right? And originally it wasn't called RX, and it came out as RX. And then a few years later, it was ported to Java, so there's now Java RX. And after that, there's now RX this and RX that, and basically trying to implement that library. You know, and you can now use RX Java in Android. In iOS, there was RX Swift. There's actually two versions of it. One was a pure port, and the other one said, no, Swift was a different language, so we need to modify their system to fit the language better. Now Apple's got their own system. But it's definitely grown from that RX from Microsoft. I mean, they weren't the originators, but they made it popular. Yes, the room is part of this, right? Because in Android you got the room, and then you update the data in the room, and then all the views that depend on the room get updated, right? Well, no, the room is not necessarily a database. We can build it to depend upon a database. Right. Another idea is instead of having a single source of data, right? We have things connected by messages, right? So we see this. A lot of systems now creating events. So in Android or iOS, you got a touch event, right? You touch a screen, and so then it just sends a touch event, and that touch event can be broadcast to whoever's interested. And so then you can register for interest in that event. And once you do that, you can also then create your own types of events, and then you could send it to the notification center, and then other components of your application can then register for interest in that event, right? And so then what happens is your components get decoupled from each other because they don't know about each other. All they know is there's a series of events that happen, and I'll register for those, and those events will have a format with this information in it. And then when I get that event, I'll respond to it. I'll take to grab the data, do something, and display it or interact, right? And so we start to see that happening. You also see this part in RX, right? Because in RX, you can have a data source and it broadcasts, and then you have this chain of things that can react to it and transform it. Not quite the same. But also, so that starts to decouple your components because now there's some sort of bus-like system or broadcast system where you just, here's an event, and then whoever interested can deal with it.
This is actually what in practice. We're building large systems, a couple messages.
Yeah,
It's just a nice way route.
do whatever they want. Right. And it makes each component independent, right? I can develop this and I don't have to worry about anybody else. And then here's my messages. And all you have to do is what information is in the message, right? And so, yeah, the next thing is, I can do the slide, is get rid of that boundary, right? And that message could be some sort of message queue. It could be Kafka, right? Or some sort of messaging system. And it doesn't have to be on the same machine, right? All of a sudden, we can now, each one of those circles could be a different machine. And then that leads us to, they call it serverless, which is like a bizarre term. Like, what do you mean serverless? No, there's still a server there, and you still connect to it, right? So, but the idea is, instead of having one big application, right, that sits on a server you interact with, you break that application into small little pieces, right? And then when you need something from that sort of pseudo application, instead of talking to one application, you talk to each individual piece, right? And those pieces may have to talk to each other to get things done, but they do it in the background, probably with a messaging system, right? But it's taking this idea of messages and decoupling things to this extreme, right? So in AWS, when you write a serverless, you write a lambda, you write a function, right? And then when clients talk to that function, right, the single function, and the goal is to break in your application into small pieces, small as possible pieces you can. And the advantages are it decouples things, right? So you can develop them independently. But people also talk about they're saving a lot of money because you only pay for when that function is in memory, right? And since it's a small little function, it doesn't take too long to spin up. And so you can basically say, look, if no one's called that function in the last hour, just get rid of it. And then if 2 hours later someone called the function again, it gets spun up, and so there's a slightly longer delay, but you know, I've seen reports of people say, "Oh, we just saved 14K a month because we broke our application into these smaller pieces," right? Like, yeah, that's pretty good savings for a month, right? And since they're on AWS, I mean, 14K that's a lot of money because their servers are pretty cheap. Right? So these are two common ideas I've seen that are trying to interact with